So this is a guide to our software, and we'll begin with the 8 main features of it. So the first feature is open source. You don't have to pay to download R, it's free and can be found on the internet. Furthermore, package customization and adding features is easy to do. Secondly, the extensive range of packages. The comprehensive R archive network contains over 10,000 different packages and extensions, and while it was once developed for academic objectives, it is also utilized in the industry now. Next is the compatibility with multiple platforms. So R allows for cross-platform compatibility, like being able to run on Windows, Mac, and Linux. It can also run on any hardware setup without the need for any specific parts. It enables quick calculations because it supports a wide range of complicated operations on vectors, arrays, data frames, and such. It also includes a variety of operator suites to execute these varied calculations. R also has a strong ability to design graphics. It has improved libraries that make it possible to create interactive graphics, making data visualization and representation simple. R can generate various flow diagrams, such as straightforward charts as well as intricate interactive charts. Next, we have data wrangling. So an explanation is that time-consuming process of cleansing large and consistent data sets in order to facilitate computation and further analysis, and R can be used for database management and wrangling. Next is R is efficient in software development because it has extensive development environment. It can be used for both statistical computing and software development. R is an object-oriented programming language and can be used to create full web apps. Lastly is no compilation required. R language is an interpreted language, not compiled, so no compiler is required to compile code into an executable program. R code is evaluated step by step and turns straight into machine-level calls, which reduces the time required to run. And this is my reference, which is called Features of R by Coding Ninja Studios. And next, we'll be moving on to how to install R. So this is how you download R software. You're just going to go into Google Chrome and type R software. And this is the first thing you'll see, the R project for statistical computing. But you're going to ignore this. You're going to go right here for Windows because we're using Windows. Or you can go from OS, which was down there just now. And then you can simply just press this and it'll start downloading, as you can see down here. So this is how you generate a random dataset. You open the random dataset generator, then you scroll to the very bottom and you type vaccine dfgen bracket 3030 is the sample size you want, and then you type vaccine to be able to see your dataset, and then in order to save it as a CSV file, you type write CSV vaccine file, and then basically like the file path, and then new file .csv, and it just saves it as a CSV file, as you can see here. And then we're just going to rename it into vaccine. So this is how you retrieve a saved CSV file. You're just going to open our software and then type vaccine, read CSV, all that. And then you're going to change the dir after clicking on the console and direct it to the folder where it's saved, and then type vaccine and you should have your file there. The first thing I want to introduce to you is t-tests, and there's two types of t-tests. One is independent t-test and the other is the paired t-test. So independent t-test is also known as a one-sample t-test and is used to compare the mean of one sample to a theoretical mean. This theoretical mean could be from a previous experiment or from an experiment with control and treatment conditions. And a one-sample t-test can only be used if the data is normally distributed. And then we have a paired t-test. So a paired t-test is used to compare the mean of two related groups of samples, and it's used when you have two values for the same samples. And a paired t-test can also only be used if the data is normally distributed. So this is a demo of how to do a paired t-test. So my research question is there a significant difference of time between the treat group and the control group? And we're just going to make some subsets first. So treat subset vaccine group equals treat, and then the control group subset bracket vaccine group equals control. And then we're just going to run that and then do normality tests, which is basically to see if the distribution is normal or not. because t-tests can only be run on normal distributions, as I've mentioned before. So Shapiro test is your normality test. And we're just going to run that for all the variables because I wasn't sure which one to do it on. And as you can see, they're all normal as all the probabilities were over 0.05. And then we're just going to revise my question. So is there a significant difference in the time to results between the treat group and the control group? And then we're just going to do a quick variance test. So var test, treat, the $ time to, control, and the ratio of the variances is less than 4, so it's equivalent, and the p-value is less than 0.05. If the p-value is less than 0.55, there's a significant difference, and if the p-value is more than 0.05, there's no significant difference. And then now we're going to run a t-test. So t-test, bracket, treat, $ time 2, comma, control, $ time 2, and the p-value discovered is 0.404, which is more than 0.05, which means it's not a significant difference. So the answer is there is no significant difference in the time to results between the treat group and the control group. The next test we're going to do is an ANOVA test. So ANOVA stands for analysis of variance and is used to compare the means of more than two groups and to see whether or not there is a difference between those means. It can only handle continuous data and requires normal distributions. It also requires somewhat equal variances between the groups of data. So there's two types of ANOVA, one-way ANOVA and a two-way ANOVA. A one-way ANOVA is used to compare the means of usually more than two groups and is used when the data is organized into several groups based on a single grouping variable. It can only be used if all the data is normally distributed and have common variance, and it focuses on one independent variable. A two-way ANOVA is used to compare the effect of two grouping variables or factors on a single response variable. Sample sizes within each level of the factor have to be equal, which equals a balanced design, and it focuses on two independent variables instead of one. So the next thing is how to do a one-way ANOVA. So you're just going to type vaccine to be able to see your data set again after all the code above. And my research question is, does the time on results relate to the marriage status of these patients? And then we're just going to make subsets again. So never, married, and divorced as 3 different subsets. And then we're just going to run it. And then just copy the normality test information so that it's easier to refer to. And then just do the Shapiro test all over again for all 3 subsets of time 1, and they all turned out to be normal, so just going to copy paste the p-values again and then do a common variance test this time. So I have to install packages car in order to do the Levine test. So now we're just waiting for the packages to install. And then we're just going to type library bracket car Levine test, because the Levine test is only available in the car package. And then yeah, so that's the formula, and the variance was equal, so now we can proceed with the ANOVA test. So result 1, and then we're just going to show a summary of result 1 after this. Yeah, and there's no significant difference as the p-value is more than 0.05. So the answer is that there is no significant difference of time and results between the 3 variables, and thus the time 1 results have no relation to the marriage status of these patients. The next thing is correlation tests. The 2 main correlation tests are Spearman's and Pearson's. A correlation test is a bivariate analysis that measures the strength of association between 2 variables in a direction of the relationship. So a Spearman's correlation test can be used with ordinal data, and variables do not have to be normally distributed. A Pearson's correlation test can only be used with continuous data, and variables have to be normally distributed. So the next thing we're going to do is a correlation test, specifically Spearman's correlation. And my research question is, what is the type of correlation between their ages and the number of kids they have? So we're just going to make some subsets again. And actually, we're just going to copy-paste it from the t-test because it's the same one. And then copy-paste the normality test section as well, just to refer to. Change the Shapiro test variables into vaccine $H, and that turned out to be not normal. And vaccine $number of kids also turned out to be not a normal distribution. So since both variables are not normally distributed, we can only use Spearman's, we can't use Pearson's. So we're going to do a Spearman's test. That's the formula, core.test, bracket, and insert all that information. And so we got the R as 0.044, so it's a weak positive relationship. So the answer is that there is a weak positive correlation between the patient's age and the number of kids they have. The final thing is parametric tests. So it makes assumptions about the shape of the distribution in the underlying population and about the form or parameters of the population distribution. And the difference between parametric versus non-parametric tests is parametric tests require continuous data, a normal distribution, and its main central theorem is the mean, and all of its population information is known. Whereas for non-parametric tests, it doesn't have to be continuous data. All data types are fine, can be any distribution. The central theorem is the median, and there's no information known about the population. The next thing is parametric versus non-parametric tests. So we're going to do a Kruskal-Wallis test, which is a non-parametric test, and it's only used when the data is not continuous or distribution is not normal, and ANOVA cannot be used instead. So my research question is there a significant difference between the incomes of males versus females? We're just going to copy paste the p-value information again, and then we're going to do a Kruskal-Wallis test. So that's Kruskal.test, gender, income, data, vaccine. The p-value turned out to be 0.462, so the answer is that there is no significant difference between the incomes of male versus female patients. So the next thing is ggplots. It's just a better way to look at your data and have it be more organized. So we're just going to install packages ggplot in order to actually utilize the packages. And then once it's downloaded, we can use library bracket ggplot in order to use the package we just installed. So for my first ggplot, the x-axis is going to be age and the y-axis is going to be score. And I'm going to be using purple dots and the size as 3 so that it looks nice. And we're just going to run it. So as you can see, the x-axis is the age, the y-axis is the score. And then we're going to run a second ggplot. So instead of age and score this time, it's going to be age and time 1. And then the color is going to be red and the size is going to be 3 as well, because that's a good size to use. So as you can see, the age is the x-axis, the time 1 is the y-axis. So in conclusion, there are so many benefits of our software, and that's why you should be using it instead of any other statistical software. And as last chance effort, so this is something interesting you can be doing to your ggplots to make it look cuter. So you can download, install packages, emoji font, and it's actually to make your ggplots look really nice and cute. So after it downloads, you can just use library, emoji font, and then just summon ggplot again as well. And we're just going to be plotting the chart. So I'll be using the same x and y variables, each score. And then for, instead of dots this time, we're going to be using cats emoji, because they're cute. And then for the color, I'm going to be using this turquoise color that I know is your favorite. And this is actually the CSS code for it, so it's 008080. And we're just gonna run it. And look, there's cats, and it's so cute. If that doesn't convince you to use our software instead of anything else you're considering, I don't know what will.